Hello, everybody. Hope you all are doing well. Today, I will talk about the idea of impulse. Before I talk about impulse, I would spend a little bit of time clarifying the concept of total linear momentum for a system of particles. Let's begin. Here I have a system of 1, 2, 3 particles. I repeat, this is a system of 3 particles, and note that if we talk about just a single particle m1, then we use lowercase p to denote the linear momentum of that specific particle. But when we talk about the total linear momentum of a system of particles, then we would be using capital P. So capital P is being used to refer to the total linear momentum for a system of particles. Since this is a system of 1, 2, 3 particles, the total linear momentum for this system would be the summation of the linear momenta of particle 1, particle 2 and particle 3. So small p1 plus p2 plus p3 would give us the total linear momentum. And these individual linear momenta can also be written in this form: m1 v1 plus m2 v2 plus m3 v3. v1 would be the velocity of particle 1, v2 the velocity of particle 2, and v3 the velocity of the third particle. So this is what we have as the total linear momentum for this system of 3 particles. That means for n particles, if we have a system where we have n number of particles, then the total linear momentum for that system containing n particles would be the summation of p1, p2, p3, p4, and we move on up to p sub n. This will then read m1 v1 plus m2 v2 plus m3 v3. It would keep on going till mn vn. Instead of writing this long summation, we can also take advantage of this form right here. What we see is the total linear momentum. The total linear momentum for a system containing n particles can also be written as the product of the total mass of the system and the velocity of the center of mass of that system. So if we know the total mass of a system of, let's say, n particles, and if we know what the velocity of the center of mass of that system of particles is, then we can just multiply those two and compute the total linear momentum for that system of n particles. Now that we've talked about total linear momentum for a system of particles, we get to the idea of impulse. Impulse, it's, in plain words, impulse is just a force applied in a short period of time. Let's get to the technical stuff that we have for impulse. Recall that Newton's second law can be written in this form. dp dt equals the net force. Now, if we just manipulate this equation, then dp would be f times dt, and integrating on both sides we have integral of dp equals integral of f with respect to the time. That means we have integration on both sides with respect to, essentially with respect to time. We integrate on both sides, on left and right side, from some initial time to some final time, from some initial time to some final time. Here on the left hand side we have 1, so integrating 1 with respect to p, we end up with p, and then evaluating p from using the initial time and the final time, we have p at the final time minus p at the initial time. On the right hand side we move on with this integral of the force with respect to time. Note that this integral is basically what we call the impulse. So this integral is known as impulse, and it is indicated by capital J. Impulse is a vector quantity, and that's the reason we have this overhead arrow over this capital J. On the left hand side we had this these two terms. Subtracting this, actually p at the initial time is the initial linear momentum, and p at the final time is the final linear momentum. So if we subtract the initial linear momentum from the final linear momentum, we end up with delta p, which is the change in the linear momentum. So the change in the linear momentum is equal to the impulse. This is what we call the linear momentum impulse theorem. To summarize, what we have done, or what we are talking about in this video, is the idea behind impulse, At first, I started with the concept of total linear momentum for a system of particles, and then I just elaborated on what we mean by impulse in plain words and what we do understand by this term impulse mathematically. This theorem at the end is very powerful, and this linear momentum impulse theorem can also be used to solve a variety of problems. Thank you.